For this video, for my Chem 101 students, what we're going to be doing is we're going to practice our electron configurations. So let's do the electron configuration of tin, which is Sn, and why don't we answer the bonus question, what about the number of valence electrons, right? How many valence electrons are there? So this is again from chapter 3. So what I would do is I would locate tin on my periodic table, and tin is right here. He's a number 50, right? So I'm going to have to go all the way, starting from here, all the way to number 50, okay? And I'm not going to make you write this much on the exam, but let's identify other things about it. It's in group what? Group 4A, right? So how many valence electrons should it have? 4. Let's double check, right? So we're going to go ahead and you can write this along with me and then I'll catch up, but it has an electron configuration of 1s2, 2s2, let me go all the way over here, 2 P1, 2, 3, 4, 5, 6, 2p6, 3s2, 3p, 1, 2, 3, 4, 5, 6. I'm going to pause at argon and I'm going to take us back, okay? So we said 1s2, 2s2, 2p6, 3s2, 3p6. That's where we're at right now, right? So we're here at argon. So let's do this next row. 4s, because we're in the S block, remember? 4s, 1, 2, so 4s2. And then remember, you step down. So this is our 3D block. So we have 4s2, 3D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3D10. So 4s2, 3D10. Okay. Now we're over here, and then we step back up. So this is 4p, 1, 2, 3, 4, 5, 6, 4p6. Okay, remember, this is the only one that's misleading. It steps down a level, right? The p's and the s's are correct. So we're at 4p6. Where did we end up? We're right here on Kr. So let's do the next row. We're now at 5, right? Because we go 1, 2, 3, 4, 5. 5, S1, S2, so 5s2. Okay. So we're here. And then we go down to 4D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4D10, right? So 4D10. So we're right here, and our last two steps are to Sn. So 1, 2. And what are these two electrons in? They are in the 5p, right? Because row 1, 2, 3, 4, 5. 5p1, 5p2. That's the electron configuration for Sn, right? The whole thing written out. So let's identify our valence electrons. We said we think there might be 4, right? Because it's in the column 4A, right? But let's actually identify those ourselves. So what's the highest energy level we go out to? We go out to energy level 1, 2. We have some 3s here. We go out to energy level 4. We also go to energy level 5. 5 is the farthest out from the center that we go, right? So we go out to 5, right? So we only have 4 electrons in the 5th energy level. So we have 4 electrons in the 5th energy level. So there are 4 valence electrons. So what does this, what else can we glean here? What else can we take from this? I believe the book has you write the valence electron configuration. So if you were to write, it asks you for valence electron configuration. That would be right? That would be that. Oh, sorry, 5p2. Sorry, I auto go to 6 because 6 is full. So we're going to do one more sample problem here, and it's a question that could be asked and is asked on the homework often. So I'm going to just fly off the seat of my pants here. It could say, how many electrons is max number for, we'll say the n equals 2, right? That's one that it would ask, right, for the second energy level. And how about for n equals 3? So for my second energy level, right, do I have an S? Yeah, right? Do I have a P? Is it possible to have a 2p? Yes, right? Can I have a 2d? No. So S carries with it how many? 2 electrons. And P carries with it a maximum of 6 electrons. How do I know that? Woo! And oh, this looks awful now, doesn't it? S carries with it a maximum of 2 electrons. So in each S row, we have 2 electrons, right? And in each P subshell, we have 6 maximum, right? So the answer would be 8. How about for n equals 3? Well, we could do it the same way we just did it. Can I have an S? Yes. Can I have a P? Yes. Can I have a 3p? Correct. Can I have a 3d? Yes. Can I have a 3f? Nope. Right? So SPDF. I can't have a 3S, P, and D. So that means I have 2, 6, and 10 to add to that. How do I know? Well, I'm going to just right here identify where is the 3S. He's right here. There's 2 electrons possible. Where's the 3p? Here. Where's the 3d? Here. If they are all filled in, I have 2 plus 6 plus 10, that's 18. So that's another question that they're going to throw at you. So this is a way to do electron configurations and calculate valence electrons, and also to identify number of electrons that are in the shells and subshells. So, all right.